Hello, humans of Earth. I come in peace. And here's the clicker as well. Nice. So this was not the presentation I was planning to hold. But a month ago, I had a flash of inspiration, and the result of that inspiration is what you're holding in your hands now, the realm of data science. So, and when I got the idea, well, I had to build my presentation totally new from scratch. So it used to be called context is king, putting the science in data science. Contexts, it's a fairly nebulous concept. And we're going to be even more vague when we talk about contextualization and contextual analysis or analysis of context, whatever you want to call it. But in general, it's a fairly easy concept. It's about creating explanatory models that can adequately represent the complexity of whatever issue, problem, or that you're studying and trying to model. This is also known as Einstein's razor, which is commonly expressed as make the model as simple as possible, but not simpler than that, which is a spiffy little aphorism. Of course, he never said that. The actual quote that this is based on goes like this. Make the components of the model as simple and as few as possible without surrendering the adequate representation of the complexity of the issue at hand. And basically that's what science is. You create explanatory models that can adequately, or at least you attempt to adequately represent the complexity of the real issue you're trying to predict or model. So that's why I get putting the science in data science. And no? Yes. Who am I to speak? So my vector, I'm a bit of an oddball in this domain. So my vector into data science is old school, small data scientific research. I'm an organizational sociologist. I like organization theory, and I like analytics. And I've been doing this since '97. And basically everything I do is contextual analysis. I love explanatory models, and I couldn't live without them. It's what I do. And I've also done the business applications of contextual analysis for product strategy and business development in different consultancies. So I've been there as well. And funny thing is, I'm actually the first sociologist in Sweden to base my dissertation on computational methods. So I was the first one to actually run simulations at the university in Sweden. And it's specifically about organizational change, adaptability, and innovation. And I spent quite a big chunk of my PhD work studying the sociology of knowledge and the philosophy and theory of science, epistemology and ontology, and all the fancy words. So I do think I have the necessary qualifications to call myself an expert when it comes to the strategy and process and organization of analytics. And I also actually perform business analytics and data science. But my forte, so to speak, is contextual analysis. I'm not a computer whiz. I can't program like Robert. I'm not a mathematician like most of you guys probably are. But I know my modeling. Anyway, this map you're holding now, it didn't come to me in this form. It was actually hard work to actually get it done. It started out like this. Two-dimensional abstraction framework, dull and boring as hell. It does contain a lot of content, though. First off, definition time, or at least distinction time. Business analytics, advanced or otherwise, is a product. And it's produced by the data science process. Business analytics as a product is then used to provide a service for decision makers. And that service is delivered by the data science, or the data scientist in the data science process. So I was thinking, so what are the main dimensions of data science and producing business analytics? The first part, now where do I have the, nice. So the horizontal here is basically, even better, old tech, old school, I like it. So over here, horizontally, we have basically the production line of analytics, where we go from raw materials transformed by algorithmic alchemy into support for better business decisions. All right. And the other dimension, going from south to north, is a strategic horizon. So down south here, we have a fairly narrow focus on our daily tasks. I mean, we have to get things done to meet our deadlines using the available tools and the available data. And we don't really have much time to actually focus on other stuff, like how this fits in with the rest of the enterprise. When we go up north, instead, that's the domain of actually thinking about. So we have various analytics projects in our enterprise. What are the synergies between them? What are the dependencies they have between them? How do we allocate resources between these projects? How do we prioritize between these projects? I mean, somewhere, when it comes to dependencies, you only not have dependencies between the different projects, you also have dependencies between data scientists and the rest of the business functions. So at some point, you have to think about sort of the big picture. How do we actually manage and run multiple parallel analytics projects efficiently? Yeah, let's stop there. I could go on. So this was a start, and sort of paints a picture of sort of what are the borders of this map. So let's start filling it in, adding some content to it. There are three types of sort of content here, and we'll start off with sort of the interfaces, resources, and landmarks of the realm of data science. And we'll start with the alpha and omega of commercial activity, the market, where we have the customer coast and the sea of suppliers, because business exists both on the supply side and the demand side, and both of them needs analytics and data science. Going to the west, we of course have the mountains of data and our data lake, and we need something to run the data on, so we have some hard infrastructure, our legacy systems, our on-premise pyramids, and of course the cloud forest. I was actually happy when I realized there is a geographical phenomenon that can be used to portray the cloud, namely the cloud forests of Iran or Costa Rica. I'm happy. And of course, we also need soft infrastructure to actually run our models. And of course, the data pipes, which here is a meandering, changing river going through a floodplain. Fairly dynamic. The most important landmark, in my view, in data science, is this little spot here, the hidden temple of accurate models. Last year, I spent 30 minutes talking about accuracy. You'll have to trust my word for it that it is important. Seriously, I'll expound a bit on that one, actually. Business analytics exist to support business decisions. That is its sole purpose in an enterprise context. Although you have to realize business value and add business value to business decisions. Otherwise, you're persona non grata. Get out of here. You're just wasting money. And unless you actually want to jeopardize the company and losing money, destroying business value by giving inaccurate predictions due to an incomplete or flawed model, because, I mean, business decisions, they can't differentiate between a good and a bad model, so they'll just use whatever they get. And if you feed them disinformation, they won't take good business decisions. Of course, you still will have a job because they never figure out it was your fault, if you're smart enough. Still, our pride as data scientists, of course, is that we should strive for accuracy in our models, relevance, reliability, usability, actionability. Well, what else do we have? User friendliness, stuff like that. And I think that's quite enough of that. Yes, I can say this, because it's a fairly nifty turn of phrase. Business analytics, or the data science process, since this is a fantasy-themed map, it probably comes to no surprise for you. I'm a fantasy nerd, and as you notice, I like puns and wordplays as well. The data science process can itself be seen as a quest. The quest to find the hidden temple of accurate models and then bring the accurate models back to our quest givers and then implement it in their backyards. So speaking about quest givers, let's look a bit on the business functions that sort of sets the context for the data science process. And again, we start with the alpha and omega, the market, where we have the stakeholder city-states. They cover both supply side and demand side. Up north, we have the forest of strategy, where the elves of orgdev and the elves of bizdev live. It's a bit of a weird place, this forest, because you can't always see it for all the trees. And when I figured that joke out, then I knew this map is going to be a winner. Moving to the west, we have the dragons of the source data, and they are powerful creatures indeed, because they actually created the mountains of data. These are our basic operations, producing lots of operational and transactional data. That's growing into mountains, and we need to deal with them. And to the south, we have the jungles of IT. That was second joke when I knew this was going to be a winner. And here live the dwarves of IT and the gnomes of R&D. Some of you who have been following the logic here of this map may wonder, so IT has no strategy. That's not the case, actually. What I'm putting here, this is the day-to-day operations, and that's mostly because our day-to-day operations run on IT. So IT does have strategy, and they have lots of it, but that's up over here in the forest of strategy, where sometimes you can find a big picture and sometimes you can't. It's hidden somewhere there. Anyway, we have 4 secondary business functions of relevance to data science. The most important of which is, of course, the sovereignty of security, which is a fairly draconian and protective state. They control the great firewall that runs across the river of data to protect it and keep outsiders out, and only letting the insiders in. Frustrating people. But of course necessary. Moving north, we have the governors of the metadata more. Fairly desolate place, but very important strategically. Moving on further north, we have the hobbits of admin. Admin is basically a catch-all term for all the shared services we find in an enterprise, like finance, HR, legal, stuff like that. And in no way is hobbit a derogatory term. Do remember that Galadriel said even the smallest person can change the course of the future. So never underestimate the hobbits of admin. And of course, the nomads of the consultanate. And they roam all over this realm. You can find them everywhere. But that's the corner where I had some space to put them in. All right. So that paints the context of our the business functions that we usually have to interact with and rely on. Yes, rely on and depend on. Let's move on to the data science functions. This is actually where I contribute some new content that actually may be of interest to at least some of you. I see, at least today, up till today, I see 16 distinctive data science functions, and in 5 groups. First group, of course, sits right inside to the alpha and omega of commercial activity, the market. Here we have 5 functions. First 2 is the merchants of context data and data collectors, because the operational transactional data in the mountains of data is usually not enough. We need more data to sort of address the complexity of the business issues we're trying to model. So we can buy ready-made sets, or we can actually go out and collect it ourselves. Time-consuming, expensive, and strategically important to choose which data are we actually going to collect and how. So not an easy decision. Niklas earlier talked about the importance of communication. Here we have the devs of Uxui and the Templars of user adoption. Extremely important. We have to visualize. We have to provide an actionable interface for the tools we provide. And the Templars of user adoption, of course, help our stakeholders to actually use the stuff we produce. Otherwise, it's useless. If they can't implement it in their systems, we don't provide business value. All right, moving west. No? Yes? Here we have the stewardship of data. 2 groups here of functions. We have the data wranglers, data integrators, and data preppers. North of them, we have the data librarians, data curators, and the data architects. Each of these, of course, are entirely essential functions without which the data science process will not be able to function in an enterprise that is aiming to adopt data-driven, analytics-driven ways of working. Moving into the central area here, we have the algorithmic alchemists. We have the feature engineers in their trackless swamp, and we have the machine learners. Do realize that the hidden temple of accurate models is, of course, in the trackless swamp. Good luck finding it. To the south, we have the coders, and they cover basically the whole length of the river of data and the river of analytics. Not to be underestimated, as none of these functions are. And of course, last but not least, we have the adepts of qual-quant and the crafters of context. So they live in and around the cities of Complex, and their job is, of course, the adequate representation of the complexities of the issues we're trying to model and predict. And that's a bit of why we're here today, or at least that's what I was asked to talk about, context analysis. So let's zoom in here on the cities of Complex. Now I'm going to make a reference that I hope at least you with children will know about. Contextual analysis is much like an ogre. If you have seen Shrek, you know that he's an ogre. He lives in a swamp. And as Shrek says, ogres have layers. Thank you. So contextual analysis is like an onion. It has layers. It has 5 layers, to be more precise. Or at least that's my view today. I love making models, and actually this is an example itself of a contextual analysis of data science. So the layers of this onion starts with our stakeholders. It is a sad fact of organizations that most business units don't know what they need. And this is actually for very simple organizational. It's a very simple answer to this, purely organizationally, because they are very, very close to their own enterprise. They have very little opportunities to view their enterprise with an outsider perspective from a bird's eye view, which means they sort of like the forest of strategy. They can't see the forest for all the trees, which is why they come to us and they want stuff. And we could accept that and give them what they want. And they will be unhappy because it won't solve their problems, usually. So the first layer of the onion is that the adepts and the crafters have to cross the chasm of communication over the use case bridge to the stakeholders and start exploring the context of the business issue itself. What is actually their problem? What do they need for us to solve? I mean, a basic example is churn. I mean, I expect most of us have heard stakeholders come to us and say, hey, we need new churn estimates. And I go, why? I'm a pain in the ass that way, by the way. I make things complicated. So I ask why. And the reason I ask why is that not all churn is bad. I mean, not all customers are profitable. We want the non-profitable customers to churn. I mean, good riddance. Who needs them? They're costing us money. And not only that, is that different types of customers, depending on sort of what type they are, have different probabilities of churn for various reasons. And also different types of customers react differently to different types of customer retention activities. I mean, you can't have one offer for all customer retention activities because that will not resonate with all of them. So you need to explore the complexities of churn, in this case, before you can actually sort of state the problem that you and your stakeholders are happy with. In this case, identifying the profitable customers who are likely to churn, but who would also respond favorably to your feeble attempts at customer retention. And now again, this is actually tricky, because how do you do that? So, and then it becomes a problem of contextual analysis. So we're all at the first layer. The second layer then is, of course, the determinants of churn. Why do people leave the company? Why do customers leave the company in the first place? What are the determinants of that choice? What are the dynamics of the interactions of the determinants? What are the mechanisms that actuate that interplay? So you have to build a theoretical model of what the hell is going on, because otherwise you won't get to the third step, which is actually finding data that addresses that issue, that could adequately represent your theoretical model. So theoretical model of churn and its dynamics. So we're going to the third layer, of course, is problem quantification. You actually have to engineer features for your model. And I want to state here very, very explicitly, variables in a dataset are not necessarily features. The features are hiding in your data, hopefully, somewhere in various disguises. You will have to abuse and torture and transform your data to get features. They will not, I mean, they are tricky little buggers. I mean, they hide, and they like to hide, like niffles, if you read Harry Potter. So you really have to chase them out. So, and that is why I've situated the feature engineers in a trackless swamp. They're tough to find. All right, you got into the third layer. The fourth and fifth layers are basically two sides of the same coin, because now you have a solution, a working model that the machine learners can implement. But you also have to consider the reality of your solution. How will it fit, both in terms of content and form, the current setup your stakeholders are using? Content-wise, you have to qualify the meaning. What does this mean for, what do these numbers mean for your stakeholders? Because left to their own devices, they will misinterpret willfully whatever you serve them. It might sound like I'm a bit bitter and cynical when it comes to stakeholders, and that is true, I am. I'm old and bitter and grumpy. And of course, then you have to consider also the form of the solution. Is it adoptable? Is it user-friendly? Is it implementable? Does it run on their systems in any way? So that's a bit of a crash course into contextual analysis. I hope I've actually made some sense. Should we do a Q&A or should I go on? What? I can talk? All right, nice. All right, so let's zoom out. Here's the full map, the one you're holding in your hands or having on the chair beside you. There's a lot of text here that is impossible to read for you. And I won't actually have time to go through all the tiny little details that I find meaningful, but probably gibberish to you. I will make one note here when I talked about, when I gave the churn example, you sort of have a distinction between northern and southern analytics. The southern analytics uses the easy way to the stakeholders. Of course, now I have to walk a fine line here. If you just give your stakeholders what they want, for instance, they want better estimates of churn, and you simply take an existing model of churn, plug your data into it, and then deliver the results. That's not necessarily a bad thing if the pre-existing model, the pre-existing theoretical model of churn is good. If someone else has done all the fiddly work with contextual analysis, then you're golden. Then you can go the easy way. The problem occurs when you take the easy way and you don't have a good theoretical model. Because then you're going to plug your data into a model that's either not applicable, incomplete, flawed, or just plain bad, and you will feed this information to your stakeholders. So, and as Dumbledore told us, we have to make the choice between what's right and what's easy. So that's sort of, if you want to go north or do you want to go south, the northern part or the southern part when you do your analytics. I always take the northern part because contextual analysis is what I do. It's not for everyone, of course, but it's a choice you have to make. I mean, sometimes you have to build a new theoretical model from scratch because there isn't a pre-existing model that you can use for algorithms. So then you have to build it. And then we come to a very important part of the interplay between the depth of qual-quant and the craftness of context with the stakeholders that I forgot to mention, that everyone else has been talking about, namely domain experts. Because since everyone else has mentioned it, I have to do it too, because it is very important. Because they know their shit. They have lots of experience with the actual issue you're trying to model. They may not have your outside view of it, and then might get testy if you sort of challenge their cherished ideas about how things work. But you have to be a good researcher and plumb their brains for all the content that is there. Because otherwise you have no hope in hell of actually building a theoretical model of how the problem works. So neither probably won't, neither do the domain experts, because if they actually knew it, you wouldn't be asked to do the analysis in the first place. That's another sad fact of organizations. If people actually knew what the problem was, they would have fixed it a long time ago. The very fact that it ends up in your lap means that they don't know either. But at least you, together with the domain experts, can come up with something that actually works if you take the time to actually explore what they know and trying to synthesize that into a quantified model. I think I'm done there for today.